equation of straight line in normal form. So सबसे पहले हम बातें ये समझते हैं कि ये फाइंड कैसे करते हैं, इसका ग्राफ कैसा होता है. तो फर्स्ट टेक एक्स एक्सिस एंड वाई एक्सिस. And that straight line might be cut both the axes, so it will be like this. And basically this one is 0, 0. And this is some perpendicular distance from origin to the given line. This is P. Now, the angle made by x-axis and this perpendicular line is nothing but it's alpha. Yeah. Now, what is the equation of normal in the straight line? So it's nothing but it's a cos x times cos alpha plus y times sin alpha equal to some P. And what is P is the distance from origin to this point. Now I am going to take one example. That is how to find the equation. So let us take one example, that is find the equation of line whose perpendicular distance from the origin is. So the question is like this: find the equation of line whose perpendicular distance from the origin that is given 5 units and the angle between the positive direction of x-axis and the angle between positive direction of the x-axis and the perpendicular is 30 degrees. Of the x-axis and the perpendicular is 30 degree. So पहले अपन क्वेश्चन समझते हैं कि कैसे इसको सॉल्व करेंगे. So it's given here. We need to find the equation of line and there is the perpendicular distance given from the origin, that is 5 units. So अगर हम इस फिगर में इस क्वेश्चंस को देखें तो यहाँ पे हमें P का वैल्यू is given, that is 5. And the angle between the positive direction of x-axis and the perpendicular line, that is 30. It means alpha is given, that is 30 degrees. So we can directly use this formula, that is x cos alpha plus y sin alpha equal to P. The formula for this equation of line is x times cos alpha plus y times sin alpha, and this is equal to P. So cos alpha is nothing but we need to find the cos 30 degree. That will give you root 3 by 2 and sin 30 degree. That is 1 by 2. Now we need to put all the values here. So x times root 3 by 2 plus y times 1 by 2 is equal to 5. Now what we need to do, we can multiply here the whole equation by 2. So we will get 2 times x or 2 root 3 times x. Root 3 times x plus y equal to 10. So finally we get the equation, that is root 3x plus y minus 10. Now similarly, one more question is for you. We can write, reduce the equation Next question is reduce the equation and the equation is given, that is 3x minus 2y plus 4 equal to 0. 3x minus 2y plus 4 equal to 0 in the form of intercept form, and find the length of the segment. To intercept form, and find the length of the segment intercepted between the x-axis. Find the length of the segment intercepted between the x-axis or between the axis. Axis means it's x-axis and y-axis both. We can take 2 minutes to solve this question. First, try to understand the question, what it's asking. It's a one equation is given. The equation of line is given, basically the general equation, that is 3x minus 2y plus 4 equal to 0. And we need to form it in the intercept form. So first we need to understand how to write the equation in the intercept form. Intercept form is nothing but x upon a plus y upon b equal to 1. The general equation of intercept form is x upon a plus y upon b equal to 1. And what is the value? What is this value a and b? A and b is nothing but it's x-intercept and y-intercept. If we have a line like this, this intercept must be a comma 0 and this one should be 0 comma b. Then we can write the equation of this line, that is x upon a plus y upon b. And in this question, equation of line is given, that is 3x minus 2y plus 4 equal to 0. So what we need to do is, we need to transform this equation in the intercept form. So what we need to do here, we can take this equation 3x minus 2y plus 4 equal to 0. Simplify it. Take this minus 4 plus 4 to the right hand side. So we'll get minus 4. Divide the whole equation by minus 4. So we'll get 3x minus 4 minus of 2y minus 4 equal to 1. Further simplification will give you x upon minus 4 by 3 plus y upon 2 equal to 1. So this is the equation in the intercept form. Equation of line in intercept form. So here we can say the x-intercept is nothing but minus 4 by 3 and the y-intercept is nothing but 2. So x-intercept, that is equal to minus of 4 by 3. And next one is y-intercept. So this is equal to 2. Now we got the points. So these 2 points are minus 4 by 3 comma 0 and This point is minus of 4 by 3 comma 0. And this one is 0 comma 2. We need to find the length of segment intercepted between axes. It means we need to find the distance, this distance. If we are going to take this one as point A and this one is B, so we need to find the value of AB. So how to find the value of AB? We can apply the distance formula here. So the distance formula says if we have 2 points x1, y1, x2, y2, we can directly write distance is nothing but square root of x2 minus x1 whole square. So the same formula, after applying the same formula, we get distance AB, that is the required distance, minus of 4 by 3 minus 0 whole square plus y2 minus y1. So 0 minus 2 whole square. So finally, we got 16 by 9 plus 4. So 25. It's not 25. 16 plus 36. 16 plus 36 is nothing but 52. The square root of 52 by 9. So that will give you 2 root 13 by 3. So this is the final answer. Now the next concept is distance of a point from a line. Distance of a point from a line. Now consider one of the points, like if we have a point like this, point A, and we have any line like this. So how to find the shortest distance or the perpendicular distance from this point to the given line? We can consider this point as x1 comma y1. We can take this point as P. And equation of this line is ax plus by plus c equal to 0. Ax plus by plus c equal to 0. And this perpendicular, so we can assume this point as PM. So distance PM will be modulus of ax1 plus by1 plus c whole divided by square root of a square plus b square. Now we can see how we are getting this. So we can draw one axis, that is x-axis and y-axis here. Obviously, any line will intersect both the axes if it's not the homogeneous. So this will intersect on the x-axis also and y-axis also. This is x and y. Here its origin, that is 0, 0. Now, need to take one point. We can take a point somewhere here. And this point is P, that is x1, y1. And the equation of line is given, that is ax plus by plus c equal to 0. Now we need to a perpendicular line from this point to this line, that is point M. Consider this point as the intersection point as point A, and this one is point B. Now join these two lines, these 2 points P to B and P to A. Now we are getting one triangle, that is triangle PAB. We can find first we need to find the coordinates of this A and B. So when this line will intersect the x-axis, it means at that time y will be 0. So when we are going to put y0 here, we will get ax plus c equal to 0. So x should be minus of c by a. So it means this point is nothing but minus c by a comma 0. Again, when this line will intersect the y-axis, at that time x will be 0. So 0 plus by plus c equal to 0. Again, y is nothing but minus of c by. The coordinates of this point is 0 comma minus c by b. Now what we need to do is we need to find the area of this triangle PEA, or you can say PAB, by using the points formula. Now, area of triangle PAB, that is nothing but half into modulus of, we have 3 points, that is x1 comma y1. Second one is 0 comma minus c by a. Third one is minus of c by a comma 0. So half into x1 times 0 minus of minus c by b, that will give you c plus c by b. Minus of minus c by b, that will give you plus c by b. Then minus of c by a, second point is here, that is minus of c by a into minus c by b minus y1. Minus of c by b minus y1. Then again, third one is plus 0 times, that is y1 minus 0. Modulus closed here. Now, further simplification, we'll get half into modulus of x1 into c by b, or we can say c by b into x1. Then minus c by a into minus c by b, we'll get plus c squared upon ab. Then minus c by a into minus y1, so plus c by a into y1, and 0 into anything will give you 0. So now what we can do is, we can take LCM here. So when we are going to take LCM, we'll get AB here, AC x1 plus B into C y1 plus C squared. Now half into modulus of AX1. I'm taking C common from this, BY1 plus C, this whole thing into C by AB. So finally, we are getting the area, that is AX1 plus BY1 plus C into C whole divided by 2 times AB. We can take the modulus here. Now, If we are going to see this triangle one more time, so you can see here one perpendicular line is given and we can easily find the base length. We can apply the triangle area of triangle, that is half into base into height. Here half into AB into PM. So area of triangle ABE or PAB, anything. So area of triangle PAB, one more time, the area of triangle PAB, that will be nothing but half into the base into height. So half into AB into PM. Now we can assume this PM distance as some D. Let us assume this distance is D. So AB will be nothing but we can apply the points formula here. Distance between 2 points. So 0 minus of minus C by A whole square. So AB is nothing but square root of 0 minus of minus C by A whole square. So it will become plus C by A plus minus C by A minus C by B minus 0 whole square. And this whole thing into PM, and PM is nothing but it's equal to D. So finally, half times square root of C squared by A squared plus C squared by B squared into D. Now we can take LCM here. So we'll get A squared C squared plus B squared C squared whole divided by A squared B squared. So it will give you half times square root of B squared C squared plus A squared C squared whole divided by A squared into B squared. Now we can take C squared upon A squared B squared common. So it will give you 1 by 2 times into D is here. So C by A into B square root of A squared plus B squared into D. And this is nothing but area of triangle EA. Now we can equate these two area. The second one and the first one. When we are going to equate these two, so we'll get AX1 plus BY1 plus C, this whole thing into C whole divided by 2 times AB, and this is equal to half into C by AB into square root of A square plus B square into D. Now from here, what we need to do, we need to find the D value, because this is nothing but this is the distance PM. We already took this PM as D. So here we can cancel this C AB, or basically 2AB. We will left with AX1 plus BY1 plus C equal to D times square root of A square plus B square. Finally, D value is nothing but AX1 plus BY1 plus C whole divided by square root of A square plus B square. So this is the final answer, the D, the distance from a point to a given line. So we can use this one as a formula to find the distance. It's exactly the same. This one is the proof. From here to here, it's proof. How to find the distance from a point to a line. If you want, you can note it down. Then I will take simple questions on this topic. I have one simple question here, that is find the distance from a point. The point is given. Find the distance from a point. The point is given, that is 4, 1. From a given line, that is 3x plus 4y plus 12 equal to 0. From the line 3x plus 4y plus 12 equal to 0, or we can take this one as 3x plus 4y equal to 12. So how to find the distance from the given point to the given line? What we need to do here first is we need to make it in the general form, that is ax plus by plus c equal to 0. We need to form this equation in the standard form, that is ax plus by plus c equal to 0. We need to take this 12 to the left hand side. So it will become 3x plus 4y minus 12 equal to 0. Now we have points, that is 4, 1. We know the distance formula. So D is nothing but modulus of ax1 plus by1 plus c whole divided by coefficient of sum of or sum of square of coefficients of x and y. So that is a square plus b square. X1 comma y1 is given here, that is 4, 1. Now what we need to do, we need to put this value in the given equation, that is modulus of 3 times x1 is 4 plus 4 times y1 is 1 minus of 12 whole divided by square root of coefficient of x, that is 3 squared, and then coefficient of b, that is 4 squared. So finally 12 plus 4 minus 12 whole divided by square root of 9 plus 16, that is 25, we'll get 5. So d is nothing but 4 upon 5. The final answer is 4 by 5. The distance from the given point to the given line is 4. This is the last question of today's class. So I'm going to wind up here. Thank you, everyone. That's all.